Hi everyone, I'm the Dadgineer here with a video about top-down modeling with sheet metal in SOLIDWORKS. I call the method I will demonstrate in this video the inserted part method and is useful for modeling sheet metal, weldments, and assemblies. I've used this method a lot in my job and it has saved me a ton of time. So, a quick outline on how this method works is first we're going to make a source part. This part will be in the shape of our assembly or weldment, and it'll just be a solid boss extrude base with the overall geometry of your desired weldment or assembly. Next, what we're going to do is we're going to create individual files for our individual fabricated parts, and we're going to insert our source part into each of these files. When that's done, we're going to convert the faces to sheet metal that we're interested in to create each individual part. And then when that's done, next we're finally going to insert all of these individual fabricated parts into our final assembly file or weldment. And we'll mate these all to the origin and everything will line up nice. So let's begin drawing the source part. Let me transition to SOLIDWORKS here. So let's do a new part. Let's name this source part. So this part can really be anything. I've used this method on something like a hydraulic tank, so this could be something like a hydraulic tank. Really anything that is going to be a sheet metal weldment is what this could apply to. So let's just do that. Let's make that simple. Let's make this 20. Let's make this 10. And that'll be good. So let's get out of that and let's make this an extruded boss base. I like to make it right. Let's go up. So let's make this 10 inches tall. Okay. So the goal on this source part, a couple things to keep in mind. What you want to do is you want to try to keep it simple. You're really only defining your overall geometry. So you don't want to turn this into something where you're defining a bunch of holes and a bunch of fillets and a bunch of those types of features. What we're trying to do here is we're just trying to define the overall geometry of our final part. So why don't we make this into do a little cutout here for maybe we need some clearance in this particular location. Let's make this 6. And let's make this 2. I think that looks good. Okay. So let's make sure that's through all. Okay. We're just going to call this done here. This is going to be our source part. I think that'll define our geometry quite nicely. Yes. So another thing to keep in mind here in this method is this is not a required point here. But another thing to keep in mind here is once you get this source part drawn, and when you're right before you're ready to insert it into your individual fabricated parts, you want to make sure that all the faces are made. The power of this method is that you can quickly change the size of existing geometry, but if you have to add new geometry, like a new face, or if we want to do a new cutout on this side as well, that's adding or removing faces, that's going to create some issues in our individual fabricated parts. We can easily go in and fix those, but it's going to be more work. So with a little forethought, you can avoid some of that work here. So let's try to, when you're done with this source part, you want to try to make it set and make it your final number of faces, essentially. Okay? So let's save this. And now let's create a new part. Okay, now let's save this part as part 1-1. Okay? So now what we want to do, now we've created our part, now what we want to do is we want to insert our source part into here. Okay, we're going to use this insert part pop out, and we're going to be using this locate part with move copy feature. This is essentially when you're inserting a part into another part, the mates don't work. You don't have mates like you do in assemblies. So when you're doing this, you want to use this locate feature. So it doesn't work exactly the same, but it's similar. Okay. So what we want to bring in is we want to bring in solid bodies and planes, and that's it. We don't want body material or part material, none of this other stuff. We want to leave it just like this. Sometimes you might want to bring in sketches so you can use, that's a case-by-case basis. But right now we just want the solid and the planes. So let's look at our features there. That looks good to me. Okay, now let's bring our part in. So what we want to do is we want to essentially mate. It's not exactly a mate, but it works the same way. Essentially mate this part, all the primary planes, to this new part that we made just now. So let's front plane to front plane, add. Top plane to top plane, add. Right plane to right plane, add. Okay, let's select that. Now we've located that right in the middle. Now we can come in here to our source part and hide our planes. Okay, so now we've created one individual fabricated part file. The next step is to look at your source part here, which is, we haven't done anything with it, so this is still the source part. We want to look at this and figure out how many parts we want in our final assembly. And this is going to depend on your press brake capabilities, basically your manufacturing capabilities, and you want to make this easy on your manufacturing process. So let's look at this. We can have one part there. That's easy. Let's do another part on the bottom. That makes sense. So that's 2. I think we could do one part to take care of all of this front and another part in the back. So that makes 4 parts. So what we're going to do is we're going to do a save as 4 times. So we're going to part 1-2, save, 1-3, save, 1-4, save. So there's your 4 parts. So let's open up part number 1 again. Okay, now let's begin the process. So now we have our 4 individual fabricated parts. Now we are going to begin converting the individual faces that we want in each part to sheet metal. So for this first part, what I want to do is I want to go to the sheet metal tab. We want to go convert to sheet metal. Okay, I think this will be, you can choose your thickness in here. You want to make sure that keep body is selected, and you want to make sure your thickness is selected, and then this setting here will be important after we start selecting faces. So let's select our first face right there, and now let's select our bend edges, or bend corners essentially. So you select every corner you want as a bend. That looks good. Select each corner you want as a bend, and I think that'll be a good part. So one thing to keep in mind here, and this will help our edges and our corners to line up for welding later and not interfere, is this reverse thickness feature. If you have it reversed into the part like this, then your edges will all interfere, because this face will also have a part that's reversed in, and then that corner will overlap. So you want to have it to where the part comes out from the face. Okay. Whenever you're done with this, you can select. And there's your part. And now you have 2 bodies in here you can see with your cut list. So what you want to do is come into direct editing and do your delete keep body feature. So let's select keep body, and let's keep our sheet metal body we just made and select that. So there's our sheet metal body, or sheet metal part. This part is now done. Let's save that. Now let's open up the second part, and we're just going to do the same thing. So I'm going to go through all of these parts and do this exact same thing. Let's make this one the top. Let's make sure it's up. Now let's go into direct editing and do our delete keep body. Keep the top. Okay, there's the top one. Now let's open up our third part. Let's make this one the bottom. Let's convert faces. And we want to keep the sheet metal body, and we will save. Okay, now our final part, this will be a wraparound part with 3 faces. So let's convert those, open up that feature. And now we'll go to our bend edges. Okay, make sure we're coming out. Okay, that looks good. Okay, now we want to come into our delete keep body feature, keep our sheet metal part, And there we go. Okay, now we're done creating all of our individual part files, individual fabricated parts. So now the next step is we're now going to make an assembly. Okay, now let's insert each of these individual fabricated parts in here. There we go. There's each of our individual fabricated parts. Let's float that. Now let's save this assembly. Let's go assembly 1-1. Okay. Now this is the fun part for me. Now we're going to mate these to the origin, and we get to see these all line up and all the corners line up perfectly. So let's open up our mate feature. Okay. Let's expand each part so we can quickly grab the planes. Scroll up to the top. And now let's open up this multi-mate mode. Let's click this button here. So what I like to do is I like to create a multi-mate folder, because inevitably down the road you're going to need to add other components to this assembly, this weldment. So with this, you can quickly keep these primary mates, these primary locating mates organized, and they're not blowing up your mate tree. It keeps things simpler. So let's start with the front plane of our assembly, and let's go down and click on the front plane of each part. Okay, let's select that. Now let's come up back to the top. Let's go to the top plane of our assembly, and we're going to select the top plane of each part. And you can see each part moving to where it's supposed to go. Okay, now let's roll back up to the top. Finally, let's do the right plane of everything. Right plane. There we go. Select. Now we'll get out of that. So now we can right click here, collapse our feature tree, and you can see these 3 multi-mate folders that were created for each of those primary planes. Just kind of keeps your overall tree cleaner, and you know what's going on easier. So that's it. This assembly is now complete, and let's look at our edges and just see how well we did and how well this looks. So let's just save this, what we did, and let's zoom in here. You can see all of these corners are automatically lining up perfectly for welding. So it's forcing it to line up like this because it's driven by that one source part. So that way all the geometry is now linked. Now what you will do, just in general practice, now you can go into each individual part file, add fillets. I'd probably add a fillet here and here just to line up with your other part. You can add your fillets, add your holes, add whatever else you need, hardware, whatever else you need in here to your individual part files. Any more features would go in here, because these aren't going to be related to your overall geometry. So let me show you the power of this method now, because you can quickly update this weldment geometry. So let's say you want to make it, let's open up our source file here. There you go. Let's put this on the left and this on the right. So let's say on our weldment, we want to make this 5 inches wider and 3 inches taller. Okay, we can very quickly do that without losing any of these corners lining up. We can very quickly do that without having to touch every part. So we come into our source part, and we're going to, I can't remember how much wider or longer I said. I think I said 5 inches wider. So let's add 5, so that's 25. And let's go 3 inches taller. Let's go 13. Okay. So let's refresh that, and we can see it got much bigger. Let's save. Now, as soon as I click into my assembly, all of these parts are going to automatically update. And there my assembly just grew, and you can see all of these corners are still lining up. I don't have any errors, and I've just quickly iterated a new size. If I wanted to add another cutout, that would be a little bit more of a difficult procedure. But with a little forethought, you can really speed up your iteration process and your design process. So anyway, I found this modeling method very helpful in my job. It has sped up my design process a lot, and I hope it helps you as well. Please stay tuned for the part 2 video on this series, and thank you for watching. See you in the next video.